Hello, and welcome to the Dreamy Science Channel. I'm truly glad you're here. Perhaps today has been a long day, or maybe you enjoy drifting to sleep while imagining stars, galaxies, and the quiet mysteries of the universe. Whatever the reason, tonight's journey is made just for you. There's nothing you need to do right now. Just let your body relax, let your mind slow down, and let your thoughts drift gently, like thin clouds floating across the night sky. Together we'll explore the universe. Slowly and calmly, from distant stars, mysterious black holes, to ancient light and faraway galaxies. Some things may surprise you, but most will settle softly, like a peaceful thought just before you close your eyes. If these gentle explorations help you relax, feel free to like or subscribe, so others can also find this quiet space. Now, if you're ready, let's begin. The universe might be even older than we think. Current estimates place its age at about 13.8 billion years, based on the soft hum of the cosmic background radiation and the slow expansion of space. Yet not all measurements agree. Observations of ancient stars and distant galaxies suggest the universe could be older, or perhaps dark energy is changing in ways we haven't yet understood. These questions don't need to rush. We ponder them gently like a soft whisper. Perhaps the beginning we know is just one chapter in a longer, stranger story. And drifting silently through the vast darkness are thousands of rogue planets, wandering without stars, like tiny boats floating across an endless night sea. Take a deep breath and exhale slowly. Feel the rhythm of the universe passing through you, gentle as waves, guiding you into a peaceful sleep. Not every planet travels around a star. Some wander alone, quietly drifting through the galaxy, untouched by sunlight or warmth. These solitary wanderers may once have belonged to star systems, only to be cast into the dark by invisible forces. Or perhaps they were born in solitude, like small, failed stars. Cold and shadowed, nearly invisible. They reveal themselves only when passing in front of distant stars or faintly glowing in infrared. Imagine billions of them scattered across the Milky Way, perhaps even more numerous than the stars themselves. Each is a silent traveler, spinning endlessly through the vast emptiness. No sunrise, no sunset, only an eternal night, interrupted occasionally by the soft twinkle of faraway starlight. The universe itself moves with a gentle rhythm. According to the standard cosmological story, it began with the Big Bang and stretches outward, ever expanding, possibly forever. But some visions tell a quieter tale, a cosmos that breathes in cycles, expanding, collapsing, and beginning again. There is no final cold, no ultimate ending, just quiet renewal, a slow turning of the cosmic wheel. Imagine drifting alongside these planets, feeling the calm and solitude of infinite space. The stars shimmer distantly, each light a whisper from another world. Time flows slowly here, measured not in hours, but in the quiet orbit of cosmic giants and the gentle drift of lonely worlds. In this stillness, the mind can rest, carried by the rhythm of the universe itself. The night stretches on, soft and unbroken, wrapping the imagination in a blanket of darkness and light. Here, between the stars, you can simply float, simply breathe, and simply fall asleep to the serene lullaby of the cosmos. At times, the universe might reach a turning point, collapsing inward like a slow cosmic heartbeat, only to rebound and begin expanding anew. Each cycle could erase much of what came before, yet subtle traces linger, whispers of earlier worlds and forgotten stars. These ideas are speculative, but they paint a mesmerizing picture. A universe without a true beginning or end, flowing in gentle rhythms across unimaginable stretches of time. One cosmos giving way to the next again and again. The oldest light we can see emerged some 380,000 years after the Big Bang. Before that, the universe was a glowing fog, so dense and hot that light could barely travel before scattering. But then, as expansion and cooling worked their quiet magic, atoms formed, the fog cleared, and light was finally free to move. This ancient glow, the cosmic microwave background, still reaches us today. A faint, persistent whisper from the universe's earliest clarity. The photons we detect have traveled more than 13 billion years, stretched by the expansion of space into gentle, cool microwaves. They carry the memory of a cosmos just learning to be transparent, a soft, enduring light threading through the vastness. Meanwhile, elsewhere in the galaxy, stars nurture planets unlike any we know. Some are forged almost entirely from diamond, worlds born from chemistry so alien that carbon outweighs oxygen and pressures are unimaginably high. These diamond planets shine quietly in their own way, reminders of the infinite variety and wonder the cosmos holds, waiting to be discovered. Imagine a dense world circling a pulsar, the silent remnant of a star long gone. Its mass, density, and composition hint at something extraordinary. The entire planet might be made of crystalline carbon, a colossal diamond. Up close, it wouldn't sparkle like a jewel. The surface is far too hot for that. But beneath, vast lattices of carbon could stretch for thousands of kilometers, a hidden treasure buried deep within. These strange worlds are rare, yet they remind us of the universe's endless diversity. Some planets are rocky, some are gaseous, and some, like this one, are crystalline. The cosmos holds surprises at every turn, each one more wondrous than the last. And then there's the universe itself, immense and unbounded. It tempts us with the thought of an edge, a place we could someday reach. But space does not work that way. According to general relativity, the shape of the universe is determined by its contents. Current evidence suggests that the cosmos is either infinite or so vast and curved that it folds back upon itself. In theory, you could journey in a straight line forever, eventually returning to your starting point, not by hitting a wall, but by tracing the gentle curve of space itself. It is much like traveling around Earth. There is no edge, only a globe that loops seamlessly. On a cosmic scale, the universe may work the same way, a boundless curvature that stretches imagination and invites the mind to wander, float and drift quietly in the infinite, not infinite in space, but infinite in journey. Long ago, our sun may have had a twin, a silent companion born from the same cloud of gas and dust over 4 billion years ago. Many stars form in pairs, and perhaps our sun was no exception. If it existed, this lost sibling would have drifted away long ago, tugged apart by the gentle gravitational pull of the Milky Way. It could still be wandering somewhere, tracing its own path around the galaxy, invisible to our eyes. Some call it Nemesis, and some stories even whisper that it might have influenced mysterious patterns of extinction on Earth, though no proof has been found. Yet the idea remains. Our sun, so steady and familiar in our sky, may once have shared its birth with a quiet partner, now vanished into the stars. Elsewhere, the universe hides even stranger wonders. A single raindrop of neutron star would outweigh Mount Everest. These stars, the collapsed cores of massive ancestors, are unbelievably dense. Just 20 kilometers wide, they carry a mass greater than our sun's, packed into a space so small that a teaspoon would weigh billions of tons. Imagine that, a tiny drop heavier than any mountain you've ever seen. A defiance of everything we know about weight, gravity, and matter. The universe stretches our imagination, inviting the mind to drift among possibilities, to float alongside lost stars and hidden worlds, to rest in the quiet, endless dance of creation. In the densest corners of the cosmos, atoms are crushed together so tightly that electrons and protons merge, forming a nearly pure sea of neutrons, a kind of superfluid neutron soup. Neutron stars are small, dark, heavy, and spin with astonishing speed. Yet in their quiet, compact mass, they hold the memory of stellar collapse, a final resting place where matter is almost entirely shaped by gravity itself. Light, too, takes its own meandering paths through the universe. Sometimes it does not travel in a straight line. In regions where gravity is especially strong, near massive clusters of galaxies, space itself bends. This curvature, called gravitational lensing, can twist and warp light, like glass refracting a beam. Through this cosmic trickery, we can see multiple versions of the same distant galaxy, appearing as arcs, smudges, or even perfect rings. They are not duplicates in space, but duplicates in vision, different journeys that light has taken to reach our eyes. In rare moments, astronomers have witnessed a single supernova explode more than once. As its light arrived via separate gravitational paths, a gentle reminder that even light can wander, pause, and still find its way home. And then there were the very first stars, burning millions of times brighter than our sun. Born from pure hydrogen and helium left behind by the Big Bang, these population 3 stars carried no metals, making them massive, blisteringly hot, and fleeting. They illuminated the cosmos for a brief moment, shaping the universe that would follow, a distant memory in the grand, ongoing lullaby of creation. Some of the very first stars may have been hundreds of times the mass of our sun. They burned fiercely, consuming their fuel in a few million years, shining a million times brighter than the star we call home. Then, in spectacular explosions, they collapsed, leaving nothing but the memory of their brilliance. Though none of these stars survive today, Their fleeting lives reshaped the cosmos. They forged the first heavy elements, seeded galaxies with light, and set the stage for everything that followed, including us. Their light has faded, yet their fingerprints linger in ancient gas clouds and the quiet architecture of the early universe. Even now, as you lie still, dark matter streams silently through your body. It is not a mist or a ghost in the ordinary sense, but a form of matter that refuses to interact with light. It neither reflects, emits, nor absorbs it, yet it has mass and responds to gravity. Our galaxy drifts within an immense halo of this unseen substance, and as Earth glides through it, trillions of dark matter particles pass through every square centimeter of your body each second. They leave no mark, make no sound, yet they are there. Ghost-like, omnipresent, and essential. Without dark matter, galaxies would tear apart, cosmic structures would never form, and the universe would be unrecognizable. What it is made of remains a mystery, but its presence shapes everything we see and everything we are. It flows silently through you, part of your world even as you sleep, unseen but present. Some galaxies, too, exist almost invisibly, glowing without a single star. In the quiet reaches of the cosmos, astronomers have found ghostly systems, full of gas and dark matter, yet showing little or no sign of star formation. Some may have lost their stars in violent encounters. Others perhaps never formed many at all. A few are nearly invisible, revealed only in faint smudges of light captured in the deepest surveys of the sky. These silent galaxies challenge our understanding of how galaxies grow and evolve. If they are rich in dark matter, why have they not built stars? If they once had stars, where did they go? These dim, quiet systems drift through space like forgotten bones of cosmic history, reminders that not every galaxy blazes with light. Some simply float, unseen, unanswered, and mysterious. Even the ancient glow of the cosmic microwave background holds secrets. Amid its faint, pervasive light lies a cold spot, far larger and colder than expected. Stretching across hundreds of millions of light years, it defies the smooth randomness that early universe physics would predict. A quiet mystery in the vast cosmic tapestry, it hints at places and processes we have yet to understand. A cold whisper from the earliest chapters of the universe, inviting our imagination to wander and drift peacefully along. Some wonder if the cold spot in the cosmic microwave background is the imprint of a vast void, or perhaps a hint of something stranger, a fleeting whisper from a collision between our universe and another in the earliest moments of inflation. No explanation fits perfectly. It remains a quiet puzzle, not a loud anomaly, but a gentle reminder that the cosmos may hold secrets we have yet to understand. Meanwhile, closer to home, the moon drifts slowly away from us, about 3.5 centimeters each year, the same pace at which your fingernails grow. This gentle retreat has been happening since the moon formed some 4.5 billion years ago. Back then, it lay much closer, and a single day on Earth lasted only a few hours. Tidal friction, the quiet tug between Earth's spinning oceans and the moon's gravity, nudges it outward in its orbit, a subtle motion invisible on human timescales, but unmistakable over eons. In the distant future, Earth and moon may become tidally locked, forever showing the same faces to each other. For now, it drifts steadily away, a soft, patient journey under the glow of its familiar light. Farther out, in the dance of distant stars, some binaries exchange their outer layers like dancers brushing past one another. In these systems, the stars orbit so closely that their outer atmospheres meet. One star can swell, spilling matter onto its companion, a delicate spiral of transfer that can be calm and steady or ignite bursts of light, rapid rotations, or even a full merger. The physics is intricate, yet the sight is strangely graceful. Two stars bound together, spinning close enough to touch, influencing each other's fates. One may be stripped down to a glowing core, while the other grows enriched and expanded. Their destinies intertwined, locked in a celestial embrace. Some of the universe's most unusual wonders, certain supernovae or tightly bound neutron star pairs, begin as these quiet, touching binaries. Even stars can share, exchange, and sometimes embrace, a gentle reminder that connection exists even on cosmic scales. And yet, the vacuum of space is never truly empty. In the deepest, darkest reaches, far from any star or galaxy, a restless activity hums beneath the silence. According to quantum physics, what we call a vacuum is alive with fleeting appearances. Tiny particle-antiparticle pairs blink into existence and vanish almost instantly. These quantum fluctuations ripple through reality, influencing particles, fields, and even contributing to the subtle energy of empty space. It is part of the mysterious force known as dark energy, quietly driving the universe's expansion. So the cosmos is not perfectly still. Beneath the apparent calm lies a hidden dance, a gentle hum of creation and disappearance, a rhythm that pulses just below the surface of nothing. And as we wander through space in thought, time itself may flow differently in distant corners, stretching, bending, and revealing the universe as an ever-changing, living tapestry. We often imagine time as steady, a constant ticking that flows the same for everyone, everywhere. But in truth, time is intimately woven with gravity, motion, and the very shape of space-time. Near massive objects, a black hole, a dense cluster of galaxies, time itself slows, stretching and bending in ways that have been measured with satellites, atomic clocks, and experiments on Earth. Some cosmologists even wonder if, on the grandest scales, time may flow at slightly different rates in different corners of the cosmos, shaped by the subtle ripples of the universe's early expansion. In a universe ruled by relativity, time is not absolute. It stretches, slows, and bends, flowing gently along the contours of space. And there is more to our galaxy than meets the eye. The Milky Way's glowing spiral of stars, dust, and gas is only the beginning. Surrounding it is a vast hidden halo, larger than the galaxy we see, an almost invisible sphere of diffuse gas, dark matter, and ancient star clusters. Stray stars drift within it, carrying secrets of the galaxy's distant past. This halo stretches far beyond the visible edges of the Milky Way, a quiet, unseen presence that binds the galaxy together, shaping its rotation and holding its luminous beauty in place. It is a reminder that the universe is often more than what our eyes can see, and that vast, gentle structures quietly cradle everything we know. The Milky Way is held together by gravity, shaped over eons by collisions, mergers, and quiet interactions. Though invisible to our eyes, we feel its presence in the gentle motions of stars and the bending of light. The galaxy we know is just the luminous heart of something far larger, wrapped in unseen arms that cradle its stars and gas. Light travels slowly across the universe, stretched and slowed by the expanding fabric of space. This allows us to glimpse the cosmos not as it is, but as it was long ago. Recently, the James Webb Space Telescope captured light from a galaxy that shone just 200 million years after the Big Bang, a mere blink in cosmic history. That light has journeyed over 13.5 billion years to reach us. The galaxy itself is small, faint, and primitive, yet it whispers secrets about the universe's earliest structures. Observing it feels like peering through a narrow window into a world we were never meant to see. Into the first chapters of the cosmos, when darkness was beginning to yield to the gentle emergence of stars, a quiet dawn in a universe that would one day become ours. On the largest scales, the universe resembles a vast neural network. When astronomers map galaxies across unimaginable distances, a pattern emerges. They are not scattered randomly. Instead, galaxies gather along thread-like filaments, separated by immense cosmic voids. This sprawling lattice, stretching billions of light years, is known as the cosmic web. Zoom out far enough, and it eerily mirrors the structure of a neural network in the human brain. Dense clusters of galaxies resemble neurons, and the filaments connecting them look like axons. Of course, the universe is not thinking, yet the resemblance is quietly beautiful, a reminder that the largest structure we can imagine and the one inside our own minds can, in form, mirror each other, shaped by entirely different laws of physics. Even stars sing, though the vacuum of space carries no sound to our ears. Deep, slow vibrations ripple through their interior gases, like seismic waves traveling through a planet, a hidden symphony of energy and motion that the cosmos hums continuously, quietly, beneath the silence of empty space. Stars carry music deep within them, subtle vibrations that make them pulse and oscillate. These pressure waves ripple through their interiors, and scientists can detect them by watching tiny changes in brightness or surface motion. This is the realm of asteroseismology, the seismology of stars. Each star has a unique rhythm, a cosmic fingerprint shaped by its size, structure, and age. By listening to these stellar vibrations, we can peer beneath their surfaces, a kind of cosmic echolocation that allows us to hear the silent music of stars across vast stretches of space. Some stars are older than the galaxies they inhabit. Galaxies are not born whole, they grow slowly, merging with smaller systems and gathering stars and gas along the way. That means some stars within a galaxy may have originated in earlier, smaller galaxies, later absorbed into larger structures. These ancient stars often dwell in the outskirts or within globular clusters, tight, shimmering groups orbiting far from the galactic core. Some are over 13 billion years old, nearly as ancient as the universe itself, quietly shining as living echoes of the cosmos' earliest moments. Some of the oldest stars carry the chemical signature of a much younger cosmos, from a time when only the simplest atoms existed and heavy elements were scarce. They are cosmic fossils, quiet survivors from before galaxies fully formed. Their light is ancient, and their stories began before much of the universe we know today even existed. Even galaxies can defy expectations. Dark matter, the invisible glue thought to hold galaxies together, explains why stars in the outskirts orbit faster than expected and why galaxies cluster the way they do. Yet astronomers have discovered galaxies that seem to behave as if dark matter is absent. Their stars move as though only the visible matter exists. Some suggest that dark matter may have been stripped away during past collisions. Others wonder if we still fail to fully understand its nature. Either way, these strange galaxies remind us that the universe holds secrets yet unrevealed, and what we take as universal may not always be so. Meanwhile, our sun sings a subtle, eternal song. Deep within, sound waves ripple through the searing plasma, bouncing from layer to layer, setting the entire star into gentle, continuous vibrations. These are not sounds we can hear, but low, slow pressure waves, far beneath human hearing. With sensitive instruments, scientists can detect them and map the sun's inner structure, listening to its quiet, ceaseless ringing. A reminder that even the stars have music, a hidden symphony flowing through the cosmos. This field is called heliosysmology. By listening to how the sun rings, scientists can map the hidden depths beneath its surface, its density, rotation, and the secret flows of hot gas. The sun becomes a vast musical instrument, complex and eternal, playing a quiet song that requires the right tools to hear. And what we learn from its music helps us understand not just our sun, but stars across the cosmos. On the grandest scales, galaxies trace the paths of something invisible. The largest structures in the universe are not made of stars or gas, but shaped by dark matter. Over billions of years, this unseen substance formed enormous filaments stretching across space. Galaxies cluster and move along these cosmic threads, like beads sliding along hidden strings. We cannot see the filaments directly, but we infer them from the motion of galaxies and the bending of light as it passes through these regions. These filaments span hundreds of millions of light years, connecting vast clusters of galaxies. Between them lie immense voids, nearly empty, silent spaces where matter is scarce. The dark matter scaffolding quietly holds the universe together, guiding the growth of galaxies and the structure of everything we can see. And yet, despite its shaping power, we still do not know what dark matter truly is. The framework is immense, unseen, and subtle, a hidden spine supporting the universe as it drifts through the cosmic night. Space itself can stretch faster than the speed of light. Normally, nothing travels faster than light, yet space is not bound by this limit. In the earliest moments after the Big Bang, space expanded so swiftly that distant regions were pulled apart faster than light could bridge the distance. This was not motion through space, but the stretching of space itself. Even now, the farthest galaxies do not flee through space. They recede as the space between us stretches. Some drift away so rapidly that their light will never reach us again. It is not a violation of physics, but a quiet consequence of how the universe behaves on cosmic scales. The cosmos does not rush, it expands calmly, relentlessly, beyond what we can follow. Our solar system moves through space in a graceful, helical spiral. While the planets orbit the sun in neat, familiar paths, the sun itself journeys around the center of the Milky Way at nearly 1,000,000 kilometers per hour. Zoom out further, and the motion of our solar system becomes a vast, twisting voyage through the galaxy, a quiet ballet unfolding over millions of years, invisible to our eyes but ever present, guiding everything we know along its path. As our sun moves, the planets follow in quiet procession. not merely orbiting but spiraling through space behind it. Their combined motion traces a helical pattern, like a twisting ribbon or a corkscrew, a silent ballet stretching across light years. Everything in space is in motion. The planets, the sun, the stars, the galaxy itself. There is no stillness, only ceaseless, graceful drift. Even as we sleep, we trace these slow spirals through a galaxy in motion, wrapped in layers of orbits within orbits. A dance so vast that we can never truly feel it. Even nothing has a temperature. Far from stars, planets, and galaxies, deep, in intergalactic space, the emptiness itself holds a gentle warmth. 7 Kelvin, just above absolute zero. This is the cosmic microwave background, the faint leftover glow from the Big Bang, stretched and cooled over billions of years. It fills the universe, everywhere, quietly recording the earliest moments of creation. In the far future, the universe may approach absolute zero, but never reach it completely. Even in the deepest void, the echo of heat lingers, a faint reminder of the universe's fiery beginnings. Beneath it all, quantum fluctuations may have shaped the cosmos itself. Tiny, fleeting blips of creation and disappearance ripple through empty space, guiding the formation of galaxies, stars, and planets. The universe, even in its quietest reaches, is alive with subtle motion, a hidden, timeless symphony stretching across space and time. At the tiniest scales of reality, far smaller than atoms, the universe behaves unpredictably. Tiny fleeting fluctuations in energy appear and vanish in an instant, a manifestation of the uncertainty built into quantum physics. Many cosmologists believe these ephemeral blips were magnified during the universe's first moments in a process called inflation. As space expanded at unimaginable speed, these tiny fluctuations stretched to cosmic proportions, becoming the seeds of all structure, the places where matter would gather. Galaxies would form and stars would ignite. In essence, everything we see today was born from the trembling of nothing. Not all stars end in dramatic explosions. Some fade slowly, and in their final stages they pulsate, swelling and shrinking in quiet, rhythmic cycles. These variable stars change their brightness over time, sometimes steadily, like a slow heartbeat across millions of years. Their pulses arise from subtle changes in their outer layers, gases expanding and cooling, then collapsing and heating again. Some stars pulse every few days, a cosmic rhythm that quietly marks the passage of time in a universe otherwise measured in billions of years. Some rhythmic stars take months, or even years, to complete a single cycle. Their slow, steady pulsations have helped astronomers measure distances across space, as their patterns reveal their true brightness. They are quiet reminders that even in death, stars can keep time, not with a ticking clock, but with a long, deliberate breath. Echoing across cosmic ages, far beyond our vision, Earth drifts inside a giant bubble of hot gas. If we could see in wavelengths beyond our eyes, we would find our solar system resting within the local bubble, a vast, glowing chamber of low-density gas, stretching hundreds of light years in every direction. This bubble was carved long ago by ancient supernovae, violent explosions that blasted shockwaves through the surrounding space, heating and clearing the gas. Today, our solar system floats quietly within this low-density expanse, surrounded by a shell of hotter gas and dust. It is not dangerous. We cannot feel it, yet it is there. A calm chamber born from past chaos, now part of the gentle backdrop of our galactic neighborhood. Far beyond, behind the enigmatic Great Attractor, lies a vast empty region, a cosmic void, stretching quietly and invisibly across millions of light years. A reminder that even in the universe's largest scales, emptiness holds its own mysterious presence. The Great Attractor is a mysterious gravitational anomaly, a region so massive that entire galaxy clusters, including our Milky Way, slowly drift toward it. Yet behind this immense concentration of matter lies something even stranger: the Deep Hole Repeller, an unusually empty expanse of space. This is no mere patch with fewer galaxies. It is a vast cosmic void stretching hundreds of millions of light years, and its emptiness seems to push galaxies away. Together, the Great Attractor and the Dipole Repeller create a quiet gravitational tug-of-war, subtly shaping the motion of our local universe. We are drawn forward by unseen mass and gently pushed back by the emptiness beyond, a cosmic dance guided by both presence and absence. Meanwhile, trillions of neutrinos pass silently through your body and the Earth, without you ever noticing. These incredibly light neutral particles are born in immense numbers by the sun, exploding stars, and even the early universe itself. They barely interact with ordinary matter, gliding effortlessly through planets, people, and stars. Occasionally, a rare collision is caught in detectors buried deep underground, revealing a glimpse of their hidden journey. Yet most continue on, unseen and unfelt, whispering across the cosmos, reminders that the universe is alive with motion even where nothing seems to exist. These neutrinos are everywhere, streaming silently through space and matter alike. Moving at nearly the speed of light, yet almost never interacting with anything. The universe is alive with motion, even when all seems still. The most massive stars can die without a bang. While we often picture the death of a star as a brilliant supernova, some of the heaviest stars end quietly. When their cores collapse under overwhelming gravity, the outer layers can fall inward without resistance, leaving no explosion, no farewell light, just sudden disappearance. This process is called a direct collapse. In an instant, the star vanishes, replaced by a black hole, silent, invisible, and crushingly dense. Astronomers have even observed stars that seem to blink out of existence, a quiet reminder that not all cosmic endings announce themselves with fireworks. Some are whispers into the dark. Galaxies too can dance. They orbit one another like moons circling distant planets, tracing slow, graceful paths through the cosmos, bound by gravity and time, moving in a rhythm almost imperceptible to us. We often imagine galaxies as isolated islands floating in space, yet many live in small groups, interacting and even orbiting one another. Our own Milky Way is accompanied by dozens of smaller satellite galaxies. The large and small Magellanic Clouds are the most famous of these companions, circling our galaxy like moons around a planet, slowly tracing long elliptical paths through space. Over eons, larger galaxies can pull stars from their smaller neighbors, forming streams and tidal tails that stretch across millions of light years. Eventually, a smaller galaxy may be absorbed entirely, its stars folded into the larger host. These cosmic dances unfold over billions of years, slow and graceful, almost imperceptible, a quiet testament to the companionship that even galaxies can share. Some of the universe's brightest explosions emerge from collapsing magnetic stars. Rare and powerful, a magnet or hypernova may outshine entire galaxies in a brief instant. Magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's. When a massive star collapses into a magnetar, releasing its energy swiftly, it produces a burst of light and radiation far more intense than a typical supernova. These events may create long-duration gamma-ray bursts, flashes of high-energy light that streak across the cosmos, fleeting yet astonishing, reminding us that even in quiet corners of space, violence and brilliance can unfold. The explosion of a magnet or hypernova lasts only seconds, yet its light can journey across billions of light years to reach us. It is one of the universe's most intense phenomena, born from a small, dense object wrapped in magnetic fire collapsing inward on itself, a brief, blinding whisper across the cosmos. When we look into space, we glimpse only a portion of what exists. The edge of the observable universe lies about 46 billion light-years away in every direction. It is not a wall nor a boundary. It is simply the furthest distance light has had time to travel since the Big Bang, stretched by the expansion of space. Beyond that lies a universe likely far larger, perhaps infinite, moving away from us faster than light can traverse. The observable universe is a bubble of vision, a window into reality, not the totality of it. Beyond it, more galaxies, more stars, perhaps more wonders that will forever remain unseen. At the hearts of many galaxies lie supermassive black holes, and not all matter that falls toward them disappears. Some is trapped by magnetic fields and ejected outward as narrow, powerful jets of plasma, traveling near the speed of light. These luminous streams can stretch for millions of light years, far beyond their host galaxies, glowing in radio wavelengths and marking some of the largest structures in the cosmos. These are the radio galaxies, titans of light and energy, quietly shaping the universe on scales we can scarcely imagine. It is a strange irony. Some of the universe's most powerful outflows arise from regions around black holes, where light itself struggles to escape. Even silence, it seems, can leave an imprint across the cosmos. Not all stars follow the same path. Most stars in the Milky Way orbit along with the galaxy's rotation, yet there are wanderers. One such star, known as 804375439, moves backward, tracing a retrograde orbit against the flow like a salmon swimming upstream. Perhaps it originated in a smaller galaxy long ago swallowed by the Milky Way, or maybe a gravitational slingshot by a black hole or dense star cluster set it on its unusual path. In a galaxy that moves with majestic clockwork rhythm, this star quietly reminds us that not all things obey the rules. Some drift their own way, subtly rewriting the motion of the cosmos. And at the center of the galaxy, an unexpected secret lingers. Astronomers examining a dust cloud there discovered ethyl formate, a molecule associated on Earth with the taste of raspberries and the scent of rum. The galactic center does not literally smell, of course. The vacuum of space cannot carry scent as air does, but the presence of these molecules hints at rich, complex organic chemistry unfolding in deep space. Interstellar clouds are filled with alcohols, sugars, and even precursors to amino acids, a quiet, invisible laboratory of the universe, brewing the ingredients of life far from any human knows. It is not life, but it is the kind of chemistry that life might one day need. Between the stars, the building blocks float silently, drifting through interstellar clouds, untouched yet full of potential. Space may not smell like raspberries or rum, but it holds the whispers of creation, hints of complexity that stretch across light years. One galaxy is slowly heading toward our own, and the journey has already begun. The Andromeda Galaxy, our nearest large galactic neighbor, moves on a collision course with the Milky Way. It is currently about 2.5 million light-years away, yet its outer halo, the vast cloud of hot gas and dark matter, already brushes against our own. In roughly 4 billion years, the two spirals will begin to merge, but it will not be a violent crash. Most stars will pass by one another without colliding. Over eons, the spirals will gracefully blend into one larger elliptical galaxy, a future system some call Milka, a slow cosmic dance, unfolding over billions of years, already in motion, and all around, the universe continues to glow softly. Every part of space, including the empty void surrounding you right now, is filled with the faint afterglow of the Big Bang, the cosmic microwave background. It is a quiet, persistent reminder of beginnings, a thermal whisper from the universe's earliest moments. Lingering even as galaxies collide, stars are born and die, and the cosmos drifts ever onward. The oldest light we can observe was released when the universe was just about 380,000 years old. Back then, the cosmos was a dense, glowing plasma. As it cooled enough for atoms to form, light was finally freed, beginning its long journey across space. Over billions of years, the expansion of the universe stretched that light into faint microwaves. Today, we detect it as a near-uniform glow in every direction, a cosmic whisper from the universe's childhood, quiet yet persistent, echoing across space and time. Not all cosmic events are loud. Some supernovae, those titanic explosions that briefly outshine entire galaxies, can remain almost invisible. Astronomers call these failed supernovae. In these cases, the core of a massive star collapses inward, forming a black hole, while the outer layers fall silently inward instead of erupting outward. Occasionally, we witness stars that vanish without a trace. No explosion, no fading light, only sudden darkness. The violence is immense but hidden, reminding us that not all cosmic deaths make noise. Some happen in silence, deep within gravity's relentless grip, and some galaxies themselves are quiet in ways we cannot imagine. While we often picture galaxies as glittering spirals or luminous ellipticals, there are others that remain almost invisible. They are vast collections of gas and dark matter, with very few stars to light their way. Floating through the cosmos like ghosts, they reveal that not all the universe's structures are bright, and that even in apparent emptiness, a hidden story unfolds, quietly shaping the cosmos. These dim galaxies are quiet presences in the cosmos. They contain very few stars, yet they still carry mass, mostly in the form of gas and dark matter. Difficult to detect with ordinary telescopes, they often appear only as faint smudges, or reveal themselves indirectly through subtle gravitational effects. Some may be failed systems, galaxies that never managed to form many stars, perhaps stripped of their gas or heated too early in cosmic history. Others may simply represent a temporary stage in galactic evolution. What they all share is subtlety. No fireworks, no swirling arms, no brilliant light, just a quiet, persistent gravitational presence. They remind us that not all galaxies shine. Some simply exist, drifting silently through the vastness of space, and sometimes even the invisible can collide. When two black holes orbit each other, they send ripples through space-time called gravitational waves. Energy leaks away as they spiral inward, until finally they merge in a single silent crescendo, two invisible giants becoming one. These cosmic dances produce no light, yet they carry enormous power. Since 2015, when the first gravitational waves were detected, dozens more have whispered their stories to us across the universe. Each signal traces the collision of massive objects in distant galaxies long ago, a quiet testament to the unseen drama that unfolds in the cosmos every instant. These black hole mergers happen quietly, invisibly, yet with unimaginable force. Entire solar masses of matter are converted into ripples that travel across the cosmos, waves that distort the very fabric of space itself. For a fleeting instant, the universe itself seems to hum, a subtle song of gravity stretching and folding. Not all stars end in brilliance. Smaller stars, like our sun, fade slowly, taking billions of years to complete their final act. As hydrogen runs out, they expand into red giants, gently shedding their outer layers into space. What remains is a dense, hot ember, a white dwarf. It no longer produces energy, yet it radiates the faint heat of its past life, cooling imperceptibly over eons. In time, billions of years from now, it will fade into a black dwarf, invisible and silent. But the universe isn't old enough for that yet. Every white dwarf ever formed still glows somewhere, quietly dimming in the cosmic night. Near a black hole, time itself bends. In Einstein's general relativity, gravity doesn't just pull on matter, it warps space and time. The stronger the gravity, the slower time moves compared to distant regions. Orbiting just outside the event horizon, minutes for you could stretch into years for someone far away. This gravitational time dilation is real, measured and profound. Black holes don't merely trap light, they stretch the rhythm of time itself. A reminder that in the universe, even time is fluid, flowing differently depending on where you are in the cosmic dance. The spaces between galaxies are colder than any laboratory on Earth. Far from stars, planets, or gas clouds, intergalactic voids reach temperatures just a few degrees above absolute zero, about 2.7 Kelvin, colder than any natural place we can touch, colder than nearly any environment we can create, even with our most advanced technology. This extreme chill comes from absence, an almost total lack of particles and energy. Only a scattering of stray atoms remains, and the faint, lingering glow of the early universe. These voids are the quietest, loneliest places in existence. Stretched across millions of light years, they are the universe's deepest shadows, holding only the whisper of creation. The universe itself has grown more transparent with time. In its infancy, light could not travel freely. The cosmos was a hot plasma, a dense fog of free electrons and atomic nuclei, scattering photons at every moment. But as expansion cooled the universe, electrons combined with nuclei to form neutral atoms. Light, finally unbound, began to move freely. This moment, called recombination, occurred about 380,000 years after the Big Bang, releasing the cosmic microwave background that still bathes the universe today. Since then, space has continued to stretch, and the universe has become ever more transparent, letting light flow quietly through the darkness. As galaxies and stars formed, they brought new pockets of light into the vast darkness. Matter spread out, and the universe became increasingly transparent, letting photons glide almost unimpeded across space. The darkness of the cosmos slowly cleared, and light began to travel freely, carrying whispers of distant worlds. In 2019, humanity captured the shadow of a black hole. The Event Horizon Telescope revealed the first direct glimpse, not of the black hole itself, which remains invisible, but of the glowing ring of superheated gas dancing around it, twisted and stretched by gravity. This black hole resides at the heart of the galaxy M87, 53 million light-years away. The image shows a dark circle, the region from which no light escapes, encircled by a luminous halo. It took years of patient collaboration, linking telescopes across the globe to form a single, planet-sized eye. And in that quiet effort, science gave us more than a picture. It gave us a window into one of the universe's most mysterious objects, glimpsed through the subtle language of light. Some galaxies, however, can be seen with the naked eye. Even without a telescope, if you look up on a clear night, the Andromeda Galaxy stretches softly across the darkness. A faint, ghostly smudge, yet a tangible reminder that we are part of a universe alive with structure and history, quietly spinning and glowing above us, on clear. Dark nights in the northern hemisphere, the Andromeda Galaxy appears as a soft, hazy oval in the sky, just barely visible to the naked eye. Over 2.5 million light-years away, The light you see began its journey long before humans even existed. Andromeda holds 1 trillion stars, more than double the Milky Way, and it drifts slowly toward us. It's almost impossible to grasp, yet you can look up and see an entire galaxy without a telescope, without filters, just the sky, your eyes, and the gentle glow of something vast and ancient, drifting quietly in the dark. In 2015, a tiny satellite named LIGO detected a whisper from across the universe, a faint ripple in space-time, born more than 1 billion light-years away. 2 black holes had collided, sending gravitational waves flowing across the cosmos. These waves are subtle beyond imagination. By the time they reach Earth, they stretch and squeeze space by less than the width of a proton. Yet with sensitive instruments, we can feel them. LIGO and its sister observatories act like delicate ears, listening to the deepest murmurs of the universe. This was a quiet confirmation of a century-old prediction by Einstein, that even in the vast silence of space, colossal events can send waves rippling outward. We can perceive a single chirp, the echo of invisible giants merging, caught by a tiny detector on a quiet corner of a small blue planet. Meanwhile, the universe continues its slow, relentless expansion. Some regions are stretching away from us so quickly that their light will never reach our eyes. Space itself flows, and galaxies drift farther into the unknown, forever beyond our sight, as the cosmos quietly unfolds around us. Even if we waited forever, some galaxies would remain beyond our reach. The space between us and them grows too quickly for light to ever close the gap. They have already slipped past a point of no return, crossing the cosmic event horizon. Over unimaginable eons, more and more of the universe will fade from our view, not because it disappears, but because its light can no longer reach us. The cosmos is not only expanding, it is quietly letting go. Galaxies drift away, light stretches, and the visible universe slowly shrinks. It is a silent process, imperceptible day by day, yet profound over billions of years. Some black holes may be older than the first stars. Most are born from dying massive stars, collapsing under their own gravity. Yet there could be black holes that formed in the universe's earliest moments, before any stars ever existed. These are primordial black holes, perhaps born from tiny fluctuations in the hot, dense soup of the newborn cosmos, where gravity gathered matter into compact knots. Some of these black holes could be tiny. Others may have grown over billions of years. We have never seen one directly, but if they exist, they could be the seeds of galaxies, clues to the mystery of dark matter, or silent witnesses to the universe's first seconds. They would be older than stars, older than galaxies, quiet fossils from the dawn of time itself. Even stranger, at the quantum level, the universe may connect in ways that seem impossible. Particles separated by billions of light years can remain linked, entangled, sharing information in ways that defy our ordinary understanding of space. Across the cosmos, invisible threads may tie distant corners together, a subtle web of connection underlying the vastness. In this quiet universe, even separation can be a form of unity, and even the most distant, unseen objects can be part of the same cosmic story. Quantum entanglement is one of the strangest phenomena in all of physics. Two particles can be connected, their properties linked, no matter how far apart they drift. Change one, and the other responds instantly, even across vast stretches of space. It doesn't send information faster than light, but it whispers that reality at the smallest scales is deeply interconnected. Some physicists imagine that this entanglement could be part of the very fabric of space-time itself, perhaps helping to hold space together. Particles born in the earliest moments of the universe may still be entangled today, stretched across billions of light years, invisible threads quietly connecting distant regions. These are quantum echoes from the dawn of time, lingering in the emptiness between galaxies. Even the vacuum of space is alive with subtle energy. Empty though it seems, no atoms, no particles, no radiation, it is never truly empty. Tiny fluctuations bubble and vanish, particles and antiparticles appearing and disappearing in a restless, invisible dance. Fields shift and ripple, creating a quiet pressure we call vacuum energy. On the largest scales, this pressure may be responsible for dark energy, the force that drives the universe's accelerating expansion. Unlike any ordinary energy, vacuum energy does not fade as the universe grows. Instead, it persists, stretching space faster as there is more of it. It is a curious and gentle paradox. The more nothing there is, the more something it becomes. In this subtle hum of quantum activity, the universe is never silent. Even in emptiness, there is motion. Even in darkness, there is presence. The quiet force of empty space may be what slowly drives the cosmos apart. Even in the vastest darkness, there is a gentle pressure, unseen yet persistent, stretching the universe ever outward. Black holes, famously dark and dense, are not entirely silent. Thanks to Stephen Hawking, we know they emit a faint whisper of heat called Hawking radiation. At the edge of the event horizon, virtual particle pairs flicker into existence. Sometimes one escapes while the other falls in. The escaping particle becomes real, a tiny, almost imperceptible bit of energy leaving the black hole. Over unimaginable stretches of time, trillions upon trillions of years, this tiny leakage can cause a black hole to shrink, to fade, until eventually it may disappear entirely. Not with a bang, not with a flare of light, but as the quietest kind of ending. A long, slow fade into nothing. And in the universe, matter is rarely what we imagine. Beyond solids, liquids, and familiar gases, most of the cosmos exists as plasma, a fluid of charged particles, electrons, and nuclei dancing freely, flowing through stars, the solar wind, interstellar space, and the immense reaches between galaxies. Plasma is everywhere, the silent, glowing medium connecting the cosmic web, carrying energy, shaping the light, and threading through the darkness. Even in emptiness, even in silence, the universe is alive. Slowly, patiently, it moves, it breathes, and it unfolds around you. Most of the visible matter in the universe exists as plasma. Unlike the solids and gases we encounter on Earth, plasma flows, hums, and responds to invisible magnetic fields. It carries electrical currents across unimaginable distances, shaping galaxies, stars, and nebulae. On our planet, plasma shows itself in lightning, fire, or neon lights, but in the cosmos it is everywhere, glowing, flowing, and quietly sculpting the universe around us. Even when we think space is still, ripples move through it. Gravitational waves are subtle vibrations in the very fabric of space and time. When massive objects, like black holes or neutron stars, collide, they send these waves outward, stretching and compressing space as they travel. They move at the speed of light, carrying the story of distant cataclysms, the mass, the spin, and the subtle warping of space itself. Though silent to our ears, these waves are measurable, gentle whispers from the universe, tiny shutters opening onto the deep motions of cosmic history. And all around, the cosmic web threads through the darkness. Galaxies gather along filaments, connected by invisible scaffolding of dark matter and plasma. The universe forms a vast, intricate lattice, stretching across billions of light years. Dense nodes where clusters of galaxies gather are linked by long, delicate threads, while enormous voids of emptiness lie in between. This network is quiet, patient, immense, a hidden architecture connecting every corner of space. Even in the vastness, everything is in motion. Plasma flows, gravitational waves ripple, galaxies drift along their filaments, and the universe unfolds around you, slowly, calmly, endlessly. Through the lens of the James Webb Space Telescope, we are not just looking far, we are looking back, peering into epochs when the universe was young, when galaxies were just beginning to take shape. Some of the light reaching us today started its journey billions of years ago, long before Earth existed, long before life even flickered into being. We are seeing echoes of the past, cosmic whispers traveling through expanding space, carrying stories of stars that may have already died, of galaxies that have since merged, transformed, or vanished. It is a quiet reminder that the universe is never truly static. Even on the grandest scales, everything moves, evolves, and fades. Galaxies form, collide, and drift along the unseen threads of the cosmic web. Stars are born and die, sometimes with brilliant fireworks, sometimes in near silence. And yet through it all, light persists, a patient traveler across space and time, revealing glimpses of worlds we can barely imagine. Observing these distant, ancient galaxies is like reading a letter from the universe's childhood, written in photons that have journeyed for eons. The cosmos is vast, often invisible and endlessly intricate, but in its subtle patterns, filaments of dark matter, glowing galaxies and yawning voids, we glimpse a quiet order, a hidden rhythm stretching across the eons. Even as we lie beneath the night sky, the universe is alive with movement and memory, quietly unfolding its story, patiently waiting for us to notice, to listen, to understand. ChatGPT Janoi. These grains absorb and scatter starlight, hiding entire stellar nurseries and galaxies behind a soft, impenetrable veil. Yet, even in darkness, the universe speaks. Infrared telescopes can pierce through these clouds, revealing stars and galaxies that would otherwise remain invisible. Glowing faintly like embers in a cosmic hearth, dust shapes the evolution of galaxies, slowing star formation in some regions while nurturing it in others. It is both a curtain and a canvas, concealing and creating, silently sculpting the light and matter around it. When we look up, we are not just seeing the bright points of stars. We are seeing only part of the universe's story. The rest lies hidden, waiting for patient eyes and sensitive instruments to uncover it. Even the emptiest-looking regions are filled with subtle structure, wisps of gas, faint magnetic fields, and the gentle hum of cosmic background radiation. Space is never truly empty. Every corner, every shadow holds a quiet story, an echo of creation, a trace of forces that have shaped the cosmos for billions of years. The universe is at once visible and hidden, luminous and shadowed, a tapestry woven from light and dark, from presence and absence, patiently waiting for us to notice its quiet intricacies. Infinity in space is more than just a number. It's a quiet concept that stretches the mind as much as the cosmos itself. Beyond the reach of our telescopes, galaxies may continue endlessly, forming patterns, clusters, and voids we will never see. Every observation is a small window, a glimpse into a vast expanse whose full scale is unknowable. Even if the universe is infinite, our experience of it is bounded by light and time. We only see what photons have reached us since the Big Bang. Beyond that horizon lies a realm of eternal mystery, untouched, unmeasured, silently existing. Space may curve, fold, or stretch in ways we cannot yet imagine. In this sense, the universe teaches patience. Some regions will never be observed, some structures will remain hidden, and yet they exist, quietly shaping the cosmic landscape. Infinity doesn't shout, it whispers, inviting reflection on the vastness beyond our perception, reminding us that even the emptiest-looking sky can be teeming with untold stories. Darkness, distance, and silence are not absence, they are waiting for the right eyes, the right instruments, the right understanding. The universe stretches on, infinite, quiet, and beautiful. The idea of before the Big Bang is a quiet puzzle at the edge of understanding. If time itself began with the Big Bang, then asking what came before is like asking what's north of the North Pole, a question that loses meaning. There may be no temporal framework, no before, only the sudden emergence of space, time, matter, and energy. Some speculative models suggest there could have been something, another universe, a quantum fluctuation, a cyclic bounce, but these remain unconfirmed whispers in theoretical physics. For us, the Big Bang marks the starting line of everything we can observe and measure, the moment when clocks and calendars could begin. It's a profound reminder that the universe doesn't owe us intuitive answers. Its origin may be fundamentally beyond experience, a quiet boundary at the edge of reason, where time itself was born, carrying with it the first heartbeat of the cosmos. Quasars are among the universe's most dazzling illusions. From our vantage point, they appear as pinpoints of light, almost like ordinary stars, yet each one is a colossal engine of energy at the heart of a distant galaxy. The supermassive black hole pulls in surrounding gas and dust, forming an accretion disk that blazes with radiation, sometimes outshining every other star in its galaxy combined. What we see is ancient light, traveling billions of years across expanding space, a whisper from the early universe. Quasars reveal both the incredible power of black holes and the subtle trickery of perspective. Something that looks tiny in the night sky can contain more energy than entire galaxies. They remind us that appearances in space can be deceiving, and that even a single point of light can hold a universe of complexity. Sometimes, discoveries are born from mistakes, yet they reveal the universe in ways we never imagined. Our Milky Way is not still. It drifts alongside Andromeda and dozens of smaller companions, moving as part of a loose family called the Local Group. And this family, in turn, is being pulled towards something far larger, a gravitational enigma known as the Great Attractor. Beyond even that, hidden behind the dense plane of our galaxy, lies the Shapley Supercluster and perhaps other unseen regions, exerting their silent influence. It is as if our entire cosmic neighborhood is sliding slowly towards something enormous, invisible yet unmistakable, wrapped in shadows and mystery. We do not know exactly what awaits in that direction, only that the universe gently tugs us along, a slow, majestic migration through the vastness of space. We are living in the universe's stellar springtime. Today, the cosmos is ablaze with stars, forming, burning, and exploding in a ceaseless cycle. But for the first few 100 million years after the Big Bang, there were no stars at all. Darkness reigned until the first stars flickered to life, lighting their surroundings and beginning the slow, wondrous process of cosmic evolution. From that first glimmer, the universe began to weave its luminous tapestry, setting the stage for everything that would follow, including us. Since those first flickers of light, star formation has ebbed and flowed, rising, peaking, and then gradually slowing. We live now in what might be called a cosmic spring, a time when new stars still ignite, though fewer than in the past, yet far more than will ever come in the distant future. One day the final stars will be born, and after that the universe will slowly darken. But for now, it remains a realm of light, bright enough to inspire wonder, quiet enough to invite rest. Star formation relies on cold clouds of hydrogen and helium, collapsing gently under gravity. Over billions of years, this fuel diminishes, locked inside stars, blown away by supernovae, or heated beyond usefulness. In the far future, galaxies will exhaust the material needed to form new stars. The stars that remain will age and fade. First the blue giants, then suns like ours, followed by red dwarfs, until even the slowest burning embers cool into blackness. The universe will not end suddenly. It will dim gradually, quietly, and gently. What remains will be black holes, white dwarfs, neutron stars, and the serene silence of a cosmos grown cold. Not tragic, just still. Most of the universe is invisible. When we gaze at the stars, the galaxies, the glowing nebulae, we see only a fraction of what truly exists. Most matter neither shines nor reflects light. This hidden substance, called dark matter, reveals itself only through gravity. Galaxies spin faster than they should. Light bends more than expected, and yet we cannot see it directly. It flows silently through the cosmos and through you, unseen, essential, shaping the universe in ways both subtle and profound. Clusters of galaxies cling together with a strength far beyond what their visible matter alone could provide. This points to a hidden presence, a silent substance more than 5 times as abundant as ordinary matter. Dark matter is everywhere, quietly shaping the cosmic scaffolding, holding galaxies and clusters in place, unseen yet essential. Light from the very first galaxies travels a long, gentle path through the expanding universe. As space itself stretches, it pulls light along, elongating its waves. Light that began as bright, youthful starlight billions of years ago now reaches us softened, shifted from visible colors into the deep reds of infrared. This stretching, known as redshift, allows astronomers to measure the distances and ages of cosmic objects. With telescopes like James Webb, we can glimpse that ancient glow, now arriving as a whisper, carried across eons by the slow breath of space itself. And there are even stranger possibilities. Some physicists propose that the universe we perceive in 3 dimensions may itself be a projection from a deeper, 2-dimensional reality. This holographic principle arises from studies of black holes, where all the information about what falls in seems to reside not in the volume, but on the surface. It is as if the universe we wander through, and even you reading these words, is a delicate projection of something far deeper, a cosmic illusion made tangible by the laws of nature. Some theories suggest the universe itself may work in ways stranger than we can imagine. What we perceive as space and depth could be a kind of mathematical illusion, emerging from information encoded on a distant boundary. It is unproven, and it likely won't touch your everyday life. Yet it whispers a gentle reminder. Reality, even at its most solid, may not be quite what it seems. Space, too, may not be as smooth as it appears. To our eyes, it flows endlessly, a seamless void. But some ideas in quantum gravity suggest that at the tiniest scales, around the Planck length 10⁻35 meters, space may be granular, pixelated, a foamy lattice beneath everything we know. Stars, galaxies, thoughts, even the quiet rhythm of sleep, all may unfold atop this fundamental texture in a universe built of invisible grains. Some stars themselves defy ordinary experience. They spin faster than a kitchen blender, their equators bulging and surfaces blurring into dizzying motion. Neutron stars, remnants of massive stellar explosions, push this to extremes. Millisecond pulsars rotate hundreds of times each second, a city-sized sphere of nuclear matter spinning faster than any blade on Earth. And as they spin, They sweep beams of radiation across the cosmos like lighthouses in the dark, ticking with a precision that outstrips our most careful clocks. Many neutron stars are locked in tight dances with companion stars, drawing in matter, spinning faster and keeping perfect time. They are some of the fastest rotators known, and some of the oldest clocks in the cosmos, ticking silently through the night. The universe itself may one day fade quietly. Cosmologists once wondered if it might collapse back upon itself, but evidence now points to a different destiny. Slow, endless expansion. Galaxies will drift ever farther apart. Star formation will slow, and the night sky will grow darker. Stars will burn out one by one. Black holes will evaporate. Matter itself may decay. Over unimaginable trillions of years, the cosmos will grow still, energy spreading thin, structures dissolving. It is a gentle, gradual silence, a heat death not sudden or catastrophic, but the universe whispering itself away as softly as it once whispered itself into being. Some galaxies are more tempestuous. At their hearts, especially around active black holes or regions of intense star formation, mighty winds surge outward, carrying gas, dust, and even young stars into the vastness of intergalactic space. These galactic superwinds can stretch for tens of thousands of light years, driven by radiation, magnetic fields, and the explosive energy of supernovae. In their quiet, relentless way, they sculpt the cosmos, redistributing matter, shaping galaxies, and reminding us that even in stillness, the universe is alive with motion and change. Over time, galactic winds can quietly strip a galaxy of its star-forming gas, leaving it calm, red, and still. Yet in doing so, they scatter heavy elements into the cosmic web, seeding the raw material for future stars and planets. In this way, a galaxy breathes. It inhales matter, ignites new life, and exhales into the void, a slow rhythm of creation and release. In the far future, the cosmos becomes an endless dark ocean. Trillions of years from now, galaxies will have drifted so far apart that each will seem utterly alone, islands in a vast black sea. New stars will cease forming, old stars will burn out, and even the faint glow of white dwarfs will fade. Only cold, scattered remnants, black holes, and the thin echo of ancient light will remain. Over unimaginably long stretches of time, black holes themselves will evaporate, and perhaps even matter will decay. What remains will be particles moving silently through empty space, slow, quiet, alone. This is the heat death of the universe. It is not violent or sudden, but a vast, still darkness, a cosmic ocean with no waves, no wind, no shore. Even now, the universe may be hiding another quiet secret. Vast regions called cosmic voids stretch between clusters of galaxies, hundreds of millions of light years across, almost empty of matter. Some researchers suggest that we may be inside one of these voids right now, drifting in a relatively underdense pocket compared to the average cosmic background. A silent, slow, expansive emptiness surrounds us, shaping the universe in ways subtle and profound, inviting the imagination to wander, drift, and rest. If it is true that we drift inside a cosmic void, it does not alter our daily lives. Yet it hints that what feels like emptiness may be part of something much grander. A quiet center of a cosmic bubble, drifting gently through a web of invisible gravity, vast and silent. Some stars are more extreme than we can easily imagine. Magnetars, a type of neutron star, are city-sized remnants of collapsed stars, wrapped in magnetic fields trillions of times stronger than Earth's. While our planet's magnetic field can guide a compass, a magnetar could erase data from thousands of miles away, distort atoms, or tear matter apart. These fields decay over time, but while active, they unleash flares and bursts of high-energy radiation, detectable even across the galaxy. Dense, silent, and wrapped in invisible force, magnetars are stars that have become memory and magnetism, echoes of extreme physics frozen in space. On the largest scales, the universe continues to astonish. In 2013, astronomers discovered a structure made of quasars, the luminous cores of distant active galaxies, stretching over 4 billion light-years. This giant quasar group is the largest known object in the cosmos, so immense that it challenges our understanding of cosmic uniformity. Theory predicts that the universe should appear relatively smooth at the grandest scales, with no structures exceeding a certain size. Yet here lies an exception, a luminous thread weaving across billions of light-years. A quiet testament to the universe's astonishing complexity. The giant quasar group is made of dozens of quasars, stretching across an immense swath of space. It hints that the early universe may have woven larger patterns than we once imagined. Whether this is a true physical structure or merely a statistical fluke is still debated. Either way, it reminds us that the cosmos is more complex and perhaps more connected than our models can always predict. Black holes, too, reshape the very fabric of reality. They do more than trap light. They twist space and time itself. As you approach a black hole's event horizon, space bends inward and time slows. To an outside observer, moments near the edge crawl almost to a standstill. The warping forms a funnel in space, steep and narrow, leading only inward toward the singularity. The closer you move, the more time and space seem to trade roles, with inward motion becoming a direction of time rather than space. There is no turning back. This is not metaphor. It is the geometry of gravity, etched into reality itself. And the universe is vast enough that some regions will never meet again. Because cosmic expansion is accelerating, some parts of the universe are already receding faster than light can travel. Even if we wait forever, their light will never reach us. Likewise, we can never send a message to them. The space between stretches too quickly. Over time, more of the cosmos will slip beyond reach, leaving each galaxy as a solitary island, drifting in an endless sea of darkness. This does not break the laws of physics. Nothing moves through space faster than light. Yet space itself can expand calmly, relentlessly, separating one region of the cosmos from another, perhaps forever. Even the rarest treasures of the universe are born in this quiet violence. Gold, the heaviest element made in a star's final moments, cannot form in an ordinary stellar core. Instead, it arises in extraordinary events. The collisions of neutron stars are the most powerful supernova. In these cosmic crucibles, atomic nuclei smash together under unimaginable pressure and heat, creating gold, platinum, uranium, and other heavy elements. These atoms are then scattered across space, mingled into gas clouds, and eventually woven into new stars, planets, and even people. Every gold ring, every tiny fleck of dust began in a cataclysmic dance of matter, a silent trace of stellar fire now resting in your hand. Gold is not just beautiful, it is ancient, stellar, and a gift from the universe's grand forge. As light travels across the expanding cosmos, it too bears the marks of space's slow, patient growth. Light from distant galaxies reaches us as it was long ago, yet stretched by the space it has crossed. As the universe expands, so does the distance light must travel, elongating its wavelength, shifting it toward the red. This phenomenon, cosmological redshift, does not slow the light or drain its energy. It is simply stretched by the quiet, unyielding expansion of space itself. In effect, the universe carries the signal across billions of years, stretching and softening it like a whispered story from the earliest times. When we look at faraway galaxies, we see more than age or distance. We see the subtle story of space itself, how it has stretched and expanded since the moment that light began its journey, a silent record of the universe's steady breathing. Long ago, before atoms formed and light could travel freely, the cosmos was filled with a hot plasma where matter and energy were tightly coupled. Pressure and gravity created oscillations, ripples of compression and rarefaction like sound waves in air. These acoustic waves left an imprint in the density of matter, a frozen echo. Today we can trace that echo in the distribution of galaxies, a preferred spacing between galaxy pairs, like a standing wave preserved across the cosmos. This is called baryon acoustic oscillation, subtle yet measurable, a fossil record of cosmic sound ringing from a time before the universe became transparent, a wave that never fades, quietly shaping the structure of everything we see. Galaxies themselves are not eternal islands. Over cosmic timescales, they interact, collide, and sometimes consume each other without a trace. Larger galaxies can swallow smaller ones, absorbing stars, gas, and dust into their vast, dark embrace. In this slow, silent dance, the cosmos reshapes itself, endlessly recycling, building, and dismantling, a quiet story written across billions of years. When a small galaxy drifts too close to a larger one, gravity gently tears it apart. Its stars are stretched into long streams, absorbed into the halo of the larger galaxy, and gradually blended until the smaller system vanishes from view. Around the Milky Way, we can still see remnants of such mergers, stellar streams arcing gracefully through the sky, once the core of other galaxies. This quiet process is known as galactic cannibalism. It is not violent but inevitable, slow and elegant. Over eons, large galaxies grow not through construction, But through gentle consumption, one galaxy absorbed into another, leaving only subtle ripples in the stars. Some stars themselves seem alive, flickering like fireflies in the night. Not all shine steadily. Some pulse, shimmer, or dim and brighten in rhythmic patterns. These variable stars change for many reasons: internal pressure waves, surface eruptions, or eclipsing companions. From Earth, they appear to blink gently in the sky, a slow stellar rhythm. Some cycle in hours, others in years. These variations are not random. Many are astonishingly consistent, acting as celestial clocks. Astronomers use them to measure distances across the universe. A single flicker, repeated over and over, revealing how far away a star is and how brightly it truly shines. Stars do more than burn. They breathe, pulse, and evolve in rhythms that stretch across eons. Black holes, too, are not always anchored at the hearts of galaxies. Some wander alone. A black hole can be ejected from its birthplace through gravitational interactions, nudged out during a galactic collision, or propelled by the recoil of a merger. Once released, it becomes a rogue traveler, drifting silently through interstellar or even intergalactic space. Invisible, unbound, it carries no companion, no orbit, no home. Its presence is felt only through gravity, subtle and relentless. Even black holes themselves can be kicked across the cosmos. When two black holes merge, gravitational waves ripple outward. These waves are not always symmetrical. If more energy is sent in one direction, the resulting black hole receives a recoil, a gravitational kick strong enough to hurl it at thousands of kilometers per second. Some are flung entirely out of their galaxies, destined to wander endlessly through intergalactic darkness. Others settle into wide, lonely orbits, silently tracing paths through the void. These kicked black holes are difficult to spot, yet astronomers are confident they exist, silent travelers propelled by the memory of their own violent collisions. Even the heaviest, most seemingly anchored objects in the cosmos can be nudged by the right wave, sent drifting through the void. Some stars are stripped down to their bare cores of crystalline carbon. When a star like our Sun dies, it sheds its outer layers, leaving behind a white dwarf. Under immense gravity, the carbon inside some of these remnants may crystallize. In other words, some stars become giant diamonds. These stellar gems are roughly the size of Earth, yet far heavier, glowing faintly with residual heat. They no longer fuse atoms, yet they shine for billions of years before slowly cooling into blackness. Some white dwarfs even pulse, ringing like a struck bell. A silent, cooling jewel floating in the darkness of space. Once a star, now a crystal of ancient fire echoing the life it once held. And when we think of the universe's timeline, 13.8 billion years may seem vast. Yet in the grand scope of cosmic history, not just tomorrow or 1,000,000 years from now, but trillions of years into the future, we are still near the very beginning. Most of the universe's story has yet to unfold, patiently waiting in the quiet depths of time. Stars are still forming. Galaxies continue to assemble. Black holes glow with the heat of falling matter. In the distant future, stars will fade, galaxies will drift apart, and the universe will grow cold and quiet. But that chapter has not yet begun. Right now, we live in a moment of light, a brief golden season when the cosmos is alive with motion, energy, and change. The past stretches wide, but the future is far grander. Supernova remnants keep expanding for thousands of years. When a massive star dies, it erupts in a brilliant supernova, briefly outshining an entire galaxy. Yet the explosion does not end with the flash. The shockwave expands outward for centuries or even millennia, sweeping up gas, dust, and anything in its path. These glowing shells of debris, called supernova remnants, emit in radio, X-ray, and visible light, their delicate filaments and turbulent clouds telling the story of the cataclysm. The Crab Nebula is one such remnant, still spreading from the explosion witnessed on Earth in 1054. Supernova remnants are the slow exhalations of dead stars, unfolding long after their light has faded. Even a single planet can twist the light from a distant star. We usually imagine gravity bending light on grand scales, by stars, black holes, or entire galaxies. Yet if a planet passes directly between a faraway star and Earth, it can act as a tiny gravitational lens, subtly magnifying and distorting the starlight. Even the smallest mass leaves a mark on the path of light, a quiet ripple in the vastness of space. This subtle effect is called microlensing, rare and delicate yet powerful enough to reveal planets we could never see otherwise, even in other galaxies. A gentle flicker in a star's light, a slight curve in brightness, and suddenly a hidden world announces itself. The planet may be cold, dark, invisible, yet its presence bends the starlight ever so slightly, whispering, "I am here." Long ago, the universe itself glowed with a brilliant orange light. In the earliest days after the Big Bang, the cosmos was a hot, dense plasma radiating intensely. As it expanded and cooled, that glow shifted. When temperatures fell to roughly 3000 degrees Kelvin, the first atoms formed and light could travel freely. At that moment, the universe would have appeared warm and orange, not the deep blue-black of night we see now, but a gentle, soft radiance filling all of space. Over billions of years, this ancient light has been stretched by cosmic expansion into the faint microwave glow we detect today. The cosmic microwave background. A quiet ember fading slowly into time. Even now, the universe does not cool uniformly. Expansion spreads the heat gradually, like a vast cosmic oven being turned off. But some regions retain warmth longer. Areas dense with matter or trapped light cool more slowly. Clusters of galaxies, for instance, hold hot gas that can stay warm for billions of years, while more isolated regions chill quickly. These subtle temperature differences shape how structures form, how stars evolve, and how long cosmic processes endure. A slow, gentle rhythm woven into the fabric of space itself. Even in a universe governed by simple rules, variations arise, warmer pockets, slower fades, subtle delays in the grand unfolding. The cosmos does not cool like a machine. It cools like weather, uneven, textured, quietly alive. Some theories of cosmology suggest that new universes could be born within our own, budding off through quantum fluctuations, black holes, or other mechanisms we do not yet understand. If this happens, it would likely occur far away, beyond observational reach. Yet in theory, it might be possible to witness the first signs, a sudden bubble of new physics expanding, tearing away from our familiar reality. We do not know if this has ever happened or if it ever will. But the idea lingers. Somewhere, sometime, the quiet darkness of our universe could give birth to something new. A beginning within an ending, a whisper within silence. The cosmos is still ringing from its earliest moments. In the first fraction of a second after the Big Bang, the universe expanded explosively in a moment called inflation. That burst left tiny ripples. Quantum fluctuations stretched across space. These ripples became the seeds of all future structures, galaxies, stars, planets. They also left behind echoes. We see them in the cosmic microwave background as subtle temperature variations, and one day we may detect them as primordial gravitational waves, faint rhythmic pulses in the fabric of space-time itself. Though the universe seems quiet now, it still carries the memory of that first vibration, like a bell softly humming long after being struck. And perhaps the most quietly astonishing fact of all, you are a way for the universe to know itself. You are made of stardust. The carbon in your body, the calcium in your bones, the iron in your blood, all were forged in stars, scattered across space and gathered into life. You are not separate from the cosmos. You are its memory, its echo, its silent witness. You are a moment of the universe made conscious, a flicker of awareness in a cosmos that otherwise only moves, burns, and cools. In this way, the universe has grown eyes, and through those eyes it gazes back at itself, wonders at itself, and dreams of itself. Even now, as you drift towards sleep, it keeps dreaming. Thank you for spending this time here, floating through the cosmos with me. We've drifted across vast distances, past dying stars and newborn galaxies, listened to ripples in space-time and echoes from the first moments of creation. And somewhere in all of it, in the light of ancient stars, in the silence between galaxies, in the quiet shimmer of dust, there was you, breathing slowly, thoughts softening, maybe already asleep. This universe holds motion and mystery, but also stillness. It carries heat and light and gravity, but it also carries peace. And the fact that we can know it, piece by piece, in calm and in quiet, is something truly beautiful. So wherever you are now, whether fully awake or drifting beyond the edge of thought, may your dreams tonight be gentle. May your body rest like starlight on water, and may you carry with you, even faintly, the memory of a universe that glows not only above you, but within you. If you happen to still be awake, you can stay and watch the next chapter. And if you'd like to drift off to more stories like this, softly told, filled with wonder, consider subscribing. There's always more to explore, one sleepy soul at a time. Good night.